Chapter 9, Lesson 11, the end of Chapter 9, Simple Interest. First, pause whatever this assignment is, check your answers. For the first page, come on back when you're ready. And check your answers here and come on back when you're ready. You all know I love questions. Bring some questions to class. Send me an email if you wish. Goal for today, I will solve, there's the action word, real world problems with simple interest. Now, what that means is, let's say you're borrowing money, $4,000, 6.5% interest rate. Question is, how much will you owe after 5 years? First, may I ask, whatever the date is, whatever the assignment number is, go ahead and write this page down, get ready for some notes, come on back when you're ready. Now, speaking of notes, ladies and gents, I've actually made a printed note sheet. If you're in class, you'll get that printed paper. If you're at home, you might choose to download the paper and to edit it on Kami as we're going through. Where have you heard the term interest? Maybe you've heard the term with bank accounts. Maybe you have a savings account. Maybe you've heard the term with loans, borrowing money, and how much will you have to pay back. Perhaps you've heard the term interest with money market accounts, bonds, stocks, any kinds of savings. So interest can be a good thing or it can be a bad thing. Now, first, let's just start with the formula. I equals P times R times T. So interest is I. P stands for principal. Now, if I use this color combination here, principal is the amount of money that's either deposited or borrowed, depending on if you're saving money or if you're borrowing money. Important thing here for rate. Rate is always written as a part, a piece, a portion. Meaning, if you have a percent and you need to change it to either a fraction, like if you have 2%, change it to a fraction, or change it to a decimal. Last but not least, when it comes to simple interest, time is always, always, always written in years. So if you are given months or decades or centuries, then go ahead and change those numbers to years. Quick example here. I'm not actually going to ask you to calculate the interest. You know what? I'm going to pause. I'm going to go back and I'm going to just try to connect what we've been learning in the past few days. So some of you have been saying, Mr. Cowan, we're working on proportions. Why is this mixed in? I don't see a proportion. Well, might I suggest percent over 100. The whole, the large amount, is the P principal. And the small piece that you get to keep as extra if you're saving, or the small piece that you get to owe as extra if you're borrowing, that's what we call the I. So essentially, this almost becomes a part versus a whole. Now, let's say I just want to know what I equals. What you could do is multiply both sides by the P principal. Of course, principal crosses off, leaving you with I equals. I'm going to rearrange things. I'm going to write principal times percent over 100, which perhaps you won't be surprised, you can also rewrite that as R, the rate. All the more reason to see that that rate either gets changed to a fraction or a decimal. Mr. Collins, something's missing. Yes, it is. What if I don't want to know the interest just for 1 year? What if I want to know it for 3 or 5 or T years? That's where that T comes in. So when you look at this formula, you don't have to have this memorized, but I do want you to see that it originates from a proportional relationship. Percent versus 100, interest versus principal, and of course, we're going to need to multiply that by the time. All right, I just wanted to show you that so that you could make that connection in your brain. This is a percent problem, but we're going to use the I equals P times R times T formula almost always. I'm not going to even calculate this out. I want us to focus on where are these numbers and where do you put what number. All right. Mrs. Ramirez is investing $400. That is the start of her savings account, so that would be the principal. The rate, on the other hand, it says she's investing it at a simple interest rate of 2%. Now remember, you do not write 2 because we need to write that percent as a percentage in either fraction or decimal form. And I'll just be honest, most of us are going to change that to decimal form. But I'm perfectly okay if you leave it as 200ths in fraction form. Last but not least, this is the part that sometimes messes up a lot of students. Mr. Callan, you said years. This says 18 months. Well, how can you convert months to years? Split it up into 12-month groups. And yes, you can write 18 twelfths. You could reduce it by 6. You could write 3 halves. Oh, shucks, you could even write it in decimal form. The point is, it's going to be 1.5 years. I'll try to remember the color combination from the previous notes page. Principal would be 400, rate would be 200ths, and time would be 1.5 or 3 halves or 18 twelfths years. I just wanted to show you that to show you how to manipulate numbers. Now let's actually do a problem. Jenny puts $1,560 into a savings account. The account pays 2.5 simple interest percent, that is. How much interest will she earn? All right, so she puts in some money, and she gets to keep a little bit of extra money. What is that interest? First thing I write the equation. Then I go back and I say, all right, 1,560 principal, 2.5%. Now wait a second, 2.5%. If that just said 2%, it would be 200ths. But this says 2% and another portion. I'm going to need that 5 there. So this is 200ths and another 5 thousandths. In other words, it'd be 25 thousandths. Always be aware of changing how to change that percent to a fraction or a decimal. I would not, I might not recommend the fraction method here because you have a decimal inside of a fraction and we don't like that. Mind you, we could always change that to 25 wholes and change that to 1,000. All right, onward we go. 3 years is the time. And of course, the question, how much interest? Multiply 1,560 times 25 thousandths times 3, and you'll get exactly 117. It's not always going to be an exact whole number, but in this case it is. So after 3 years, Jenny will earn $117 simple interest from this account. Pause if you need to rewind. Otherwise, let's continue on. Mrs. Hanover borrows, here we're talking about borrowing, $1,400 at a rate of 5.5% per year. Question says, how much simple interest will she pay if it takes her 8 months to repay the loan? Now notice the question is only asking how much extra interest. Principal, $1,400. Rate 5.5%. Look, if it only said 5%, it'd be 500ths, but this says 5.5%. So we have 500ths and then another part of 100. Sorry for that interruption. And 8 months. Oh, I almost put 8 in here. Remember, we got to change that to years. So you may use 8 over 12. You may use 2 over 3. I would not suggest a decimal in this case because this decimal goes on forever. But if I were to use a calculator for this problem, 1,400 times 55 thousandths times 8 twelfths, $51.33 extra. So she would not just repay the 1,400, she would pay extra $50 on top of that. And of course, once you borrow more and more, that interest rate would go up and up and up. If you wish, pause, do this problem, and come on back when you're ready. All right, what do we got here? We have a principal of $425. We have a rate of 9 9/10%. So again, if it were only 9%, it'd be 900ths. This has got a little part after it, kind of weird. And the question says after 1 month. So we're going to write not just a 1 month split into parts to make years would be 1/12. Now, folks, you might be tempted to say, well, this is awfully close to $3.51, but I need to stop you right there. The question does not say how much interest. If you borrow $425, which is essentially what a credit card is, they're not going to say, please just pay me $3 back. That's all. We're just going to be nice like that. That's not what they're going to do. Yes, you will owe $3.51 of interest, but you also need to pay back the original principal. In fact, our textbook, well, you'll see this equation. You need to pay the $425 back along with that extra interest. So the final answer in actuality is $428.51. Please be careful. What is the question asking? If it was asking for interest, all you got to do is say 351. But if it's asking how much must be paid back in the end, don't forget to add the principal 425 together with the interest to find $428.51. Now, I got a little question for you. Let's say you're investing money, $1,500, and you get to choose between investment company A, 3% interest for 30 years, or investment company B, 4.5% interest for 15 years. I want you to just make a prediction right now. Would you rather have A or B? You got 5 seconds. Now let's find out. Now, in this case, you want the whole money back. So let's do that principal plus the extra. Let's not just find the extra. So we get $1,500 plus, and this is where we're going to multiply everything else. Oh, P.S. That's going to look mighty familiar when we start to set up this problem, because in both problems, you pay $1,500. Uh-oh, I'm going to run out of space, aren't I? All right, 3% on the left means 300ths exactly, not 3,000ths. Don't put that decimal in the wrong place. 30 years. Versus the other side, we only have 15 years, but be careful with this 4.5%. If it said 4%, it'd be 400ths. It's got 4.5. So we've got 0.0, I'm going to make that decimal a little bigger, 0.045. Now, pause if you want. You may calculate it on your own if you wish. I have done my own calculations with this and found that on the left, smaller interest rate, I would even say much smaller, but for extra time, and we end up with $2,850. All right, let's take a look at the right. Much higher interest rate. Yeah, there's less time, but let's find out what happens. In this case, if my calculations are correct, that's not right. I think it's 50. Oh boy. Should have had this prepared in advance. So when you look at this, ask yourself, which is more powerful? And if you look, investment A, which very few people usually choose, they almost always gear themselves, I want the higher interest rate, Mr. Cowan. Yes, but time, ladies and gents, is a powerful thing when it comes to investing or borrowing. The longer you invest for, that money will build and build and build. Or if you're borrowing, the shorter time that you borrow, the less it will hurt. Because if you have a loan for longer and longer, you're going to be paying more and more and more. All right, I'm going to ask you to pause. I want you to start up problem number 1 from the homework. Come on back when you're ready. Here we go with principal times rate times time. I always write that first. I'll try to stick to the coding, the colors. What do we got? 1,600, that would be the principal. Rate of 14%, 1,400ths. Don't turn that into 14,000ths. Time says 3 years, no need to change that. And go ahead if you'd like, calculate that out. And if my numbers are correct, what I found to be the answer was $672. Now listen, this question doesn't ask how much money in total, it just says how much interest. So that's all I need. Don't add the 1,600 back in there. All we want to know is, well, hey, it's a good amount of interest. All right, carry on, please. I would like to do one more example, and I find this one to be quite challenging. Okay, Justin borrowed some money, $500, 2 years, paid $105 in interest. What is the, whoa, what? What did that just say? It says, what is the interest rate? Take a look at what we have. We have the principal, how much he borrowed. We have the time, 2 years that he did it, And we have the interest now. What we don't have is the rate. Well, that's fascinating. Now, one could argue that you could change around the order, multiplication after all is commutative, and then say, Mr. Kahn, why would we write 500 times 2 when we could simply write 1,000? So now we have an equation, 105 is equal to 1,000 times r. Of course, I don't want to know what 1,000 r's are equal to. I want to know what a single r is. So we can divide that by 1,000 as long as we are fair to both sides. Now that will leave us with what we wanted. The r rate equals, and in this case, you have a tiny little decimal. And while that's a good answer, it's not a great answer because we really would list rates as percentages. So I see 10% and then I see another part of a percent. I'm seeing 10.5%. Ladies and gents, look at how this problem is similar to all the previous problems. Still the same formula. I equals P times R times T. Still gave us the principal. Still gave us the time. Look at how they're different. This particular problem gives us the interest and we are missing it. And sometimes I even circle what we're missing so I know what we're solving for. We want r equals. So now go ahead and simplify. Instead of writing 500 times 2 times r, we can write 1,000 times r. And if we want to solve for r, we're going to divide both sides by 1,000, get 105 thousandths, and while that's a good answer, it's not a great answer. Change it to 10 and 5/10%. All right, at this point, I want you to try the same thing with number 7, and let's see what you come up with. Pause the video, come on back when you're ready. Once again, question here, what is the interest rate? I immediately circle that. That is what I do not know. What I do know, paid $120 in interest. I also know borrowed $600 and 2 years, no need to divide or multiply that. Now let's go ahead. We want to solve for r, right? So I'm going to write 120 is equal to, well, let's go ahead and simplify. 600 times 2 times r, you could just write is equal to 1,200 times r. And I don't want to know what 1,200 r's are, so let's go ahead and cancel that out. Oh, anything you do to one side, be fair to the other to keep that a equivalent relationship. Now, in this case, ladies and gents, you would get precisely 1/10, but I would argue the best answer for this is to change it to a percent. So the interest rate for this particular debt would have been a 10% simple interest rate, which is pretty stinking high. All right, folks, as you can see, these problems are, well, I feel they're more challenging. I showed you a long time ago that they originated from proportions. It's still a relationship. In this case, the relationship is I interest is equal to P principal times rate times time. Don't forget the key things we talked about. The rate should always be written as a percent, but if you use it in a problem, you'll want to change it to its fraction or decimal form. T time must always be written in years. And make sure you know what the question's asking. Sometimes it's going to say, what is the rate? Sometimes it's going to say, how much interest? Other times it's going to say, how much in total, or how much is owed, or how much do you have as your final amount in your bank account? So make sure you understand what the questions are asking. All right, folks, take care, do well, let's grow. See you.